Hello Year 4, it's Miss Lewis here. Welcome to Tuesday's maths lesson. As always, we're going to start with Give Me 5. So get yourself a 5-minute timer, make sure you've got a piece of paper and a pencil, pause the video and come back after 5 minutes. Okay, well done. So our first question, put 48 into 3 groups. Okay, hopefully you would have seen the word groups there and know that when we're dealing with groups, we are looking at division. Okay, so we need to do 48 divided by 3, and if you did that, you would have got 16. Okay, next question, 5,386, add 3,592. Okay, all that was needed here was just a column addition. So you should have got the answer 8,978. Okay, next one. What is a quarter of 60? Bit of a tricky one. Here's how we normally write a quarter. Like this. Okay. Or we can show a quarter. It's something. We split it into 4 and each one of these pieces is a quarter. So when we're quartering something, we split it into 4 pieces. So you could have either done 60 divided by 4, or you could have halved 60, then halve it again. So that's what I'm going to do. I know that half of 60 is 30. And now I need to do half of 30, and I know already that that is 15. But if you're not sure, you could have done 30 and divided it by 2 like this. So how many 2's fit into 3? Well, 1 does, with 1 left over. Oh, I haven't put my 2 in. There we go. How many 2's fit into 10? 5. Okay, so our answer there is 15. Next one, 4,723 take away 2,999. Now you could have done this in a column subtraction, that would have worked, or you could have added 1 onto this number to make it 3,000, and then you're just focusing on the thousands column. So this number take away 3,000 will be 1,723, and then we need to add back on that 1 to get 1,724. Well done if you did it either way. And last question then is a multiplication one, so I'm going to use our column multiplication. So I've got 32 times by 5. Okay, so 2 times 5 is 10. 5 times 3 is 15, but I need to add on this 1. 15 add 1 is 16. So my answer here then is 160. Well done if you got any of those right. You did a super job. Let's look then at what we are doing today. So today we are challenging ourselves with the mind workout of this chapter. But first, before we do that, let's look at this line graph. I would like you to think of 3 pieces of information that you know just by looking at this line graph. Okay, so remember, all graphs need to have titles, the axes need to be labelled, and they need to have some sort of scale along both axes, okay? So I want you to have a look, pause this video for a little minute, have a look at this line graph, and I want you to pick out 3 different pieces of information that you know just by looking at the graph. Okay, super. There is loads of information to choose from. You could have said it's a graph about sunflowers. Okay, that's what we find out from the title. We can see here that we are measuring the sunflower's height in centimetres. We can also see that we are measuring the time in days. So sometimes we measure time in hours, but this one we're measuring them in days. Okay, we know here from the little sentence about it that this is a line graph showing sunflower's growth. It was planted on the 30th of July and its height was measured every 2 days. Okay, so we can see that when we've got these days, we're missing one out in between. So Saturday, didn't measure on Sunday. Monday, didn't measure on Tuesday. Wednesday, and then along it goes again. Okay, you could have said that the sunflower's height was increasing. When we see a line graph and it goes up, we know that it is increasing. You could have said that on the first few days it stayed the same height, so it didn't grow at all. It was 0 centimeters. Then it started to grow steadily. Then it had a bit of a time where it stayed the same for a couple of days, and it went up a little bit, and then it went up, and by the time you reached Wednesday the 31st, it was starting to even out and stay the same. Okay, so we can tell all of that information about this sunflower just by looking at this graph and its labels. Okay then, on to our mind workout for the day. So, if you think that you want to challenge yourself and have a go at this yourself, then go for it. You can pause the video. If you would rather work through the mind workout with me, then we can do it together. Okay, here are some patterns formed using squares with the same perimeter. The perimeter of each square is 4 centimeters. So just to know, the perimeter is the length of the outside of a shape. So here the perimeter of each little square is 4 centimeters. Okay, so 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. So each line is 1 centimeter. When the squares are put together to form a rectangle, the perimeter changes. Okay, so the perimeter is just the outside of the shape. This red line here. So we know we've got 1 centimetre along here to this bit, 2, 3, 4 to here, 5, 6. Okay, so that's what perimeter means. So our first step then is to complete the table below. So this is figure 1, figure 2, figure 3, figure 4. Number of squares used. So how many squares are used here for figure 1? Yep, only 1 square. And what's the perimeter of our figure? Well, we worked that one out before. 1, 2, 3, 4 centimetres. So I can put 4 here. Because it's already put centimetres in the title part of the table, I don't need to write centimetres on here because we already know what we're measuring in. Okay, figure 2. How many squares are used? 1, 2. And what's the perimeter of the shape? So we did that before. We did 1 to here, 2, 3, 4, 5, 6. 6 centimetres. Next one. How many shapes are used here? How many squares have we got? 1, 2, 3. Well done. 3 squares. And what's our perimeter then? Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8 centimetres for our perimeter. Brilliant. And the last one then, figure 4, we have used 1, 2, 3, 4 squares. And then our perimeter is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimetres. I can see part of the pattern forming here in our table. I hope you can too. Second step then is to draw a line graph to show how the perimeter of each figure changes with the number of squares used. Okay, it's going to be a little bit tricky for me using the whiteboard here, but I'm sure yours when you come to do it on your workbook question will be a lot better. Okay, so number of squares used, 1. Perimeter of figure 4. So we can see our scale here is going up into, so 2, 4, 6, 8, 10. It's always important to see what your scale is going up in first. Okay, so number of squares used, 1, and perimeter of shape 4. So I'll draw my little point there. Number of squares used, 2. Perimeter of figure was 6. 3. Number of squares used, 3. Perimeter of figure was 8. To get my dot just at the intersection. Number of squares used, 4. Perimeter of figure was 10. What can you see about our graph then? I think it's going up quite nicely. We join the points up to predict the perimeter of other shapes. But some people think we should not do so. Why? Well, usually with the line graph we can join up our points, but we can go even further. Using a ruler, we can go even further than this and join our line on. Mine will be a bit wonky because I can't use a ruler here. But here we go. Have a think. Why do some people think that we shouldn't do this? Yeah, it's because we've not measured this. We've not got the points here. We don't know that this will be right, but it is a prediction, a sensible guess. Okay, so if we make sure that we're just saying it's a prediction and we're not saying it's a fact, that's okay. So question 3 wants us to use the graph to find the perimeter of the figure formed by using 10 squares. Okay, so let's have a look then at our line drawn. Go to 10 squares, let's go all the way up and see where we reach. Okay, we've got to here. Now let's go along. Actually, I've seen here that my line isn't quite straight. I need to make sure that my line is totally straight to get it to work. Okay. I'm just going to plot in some points that I think will help me to draw this line a bit straighter. There we go. But yours will be fine because you're using a ruler. There we go then. So we've got to 10. We go up. And then we can go along. We come out here at 22. Okay? So we can predict that when we form the figure using 10 squares, the perimeter will be 22 centimetres. Okay, so well done if you had a go on your own and got those right. That's super. Now we're going to go on to our workbooks. Okay, so it's the same sort of thing. Here are some patterns formed using matchsticks. Complete the table. So number of triangles you can see. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. And how many matchsticks were used. So on figure 2, 1, 2, 3, 4, 5 matchsticks were used. You're then going to take the information you do in this table and draw a line graph to show how the number of matchsticks used changes with the number of triangles formed. Okay, and then you'll carry on your line when you've got it to be able to predict how many matchsticks you'll need to form the pattern that has 10 triangles. Okay, so this is for you to have a go at on your own. So pause the video, have a go, and then come back for the answers. Okay, then here we have got our answers. Okay, so this is what your table should have looked like. Okay, so number of triangles go up, number of matchsticks go up. Okay, and here is our line graph. So they pop these points in here that even though we don't know what happens with 15 matchsticks, we can predict it. Okay, predict the number of triangles. Okay, so the question 3, how many matchsticks are needed to form the pattern with 10 triangles? We need to go to 10 triangles, go up, and you should have joined your line all the way along with a ruler to find that we get 21 as our number of matchsticks. It says, does your answer agree with the graph in question 2? Does it work out? So if you wanted to check your answer, you could have gone up in the table, because you can see that this is going up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are going up in 2s, but on the odd numbers. So 3, 5, 7, 9, 11, then, oh, Miss Lewis, 13, 15, 17, 19, and 21. Okay? So this might help you. So well done for trying that mind workout. They're tricky because they make us think and use the skills that we've been learning in the chapter. If you think you've challenged yourself enough with maths today, then that's fine. You can stop your maths lesson now. If you would like even more of a challenge, we have got this activity. So the table shows the number of books borrowed by pupils from the school library over a period of 5 months. Hannah says that the greatest monthly increase in the number of books borrowed was from September to October. Is she correct? He wants you to draw a line graph to help you explain your answer. Okay, so your task then is to draw a line graph using the information in this table and see if Hannah is correct.